Welcome, everyone. I'm really excited for the new Fall 2020 Midday Talks with our inaugural speaker today, Fadi Masoud. But before then, I just would like to start the lecture series by acknowledging that the land that we're meeting on is a traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe of the Chippewa, the Haudenosaunee, and the Wendat people is now home to many diverse First Nations, Inuit, and Métis peoples. All settlers, including recent arrivals, such as myself, have a responsibility to consider what it means to acknowledge the history and the legacy of colonialism in this and other lands. And also special to today, and consistent with the University of Toronto Moment of Silence, we will be observing at 1 p.m. a moment of silence to honor all of those who lost their lives in the devastating crash of the Ukraine International Airlines Flight 752. This will be coming in the middle of the lecture, and Fadi will prompt us when 1 o'clock starts. So, I'm very excited that Fadi has agreed to be our inaugural speaker, as I think he deals and presents some very pressing issues that's very current and at the macro scale to our living environment. Fadi Masoud is the Assistant Professor of Landscape Architecture and Urbanism at our school, Daniel's faculty. His research and design work engages the landscape and its underlying environmental systems as forces in shaping urbanism. Prior to joining here, Masoud co-led research at MIT's Leventhal Center for Advanced Urbanism, where they researched and designed projects on coastal urbanism, urban codes, and the future of suburbia. His current work continues this trajectory, establishing relationships between large-scale dynamic environmental systems and planning frameworks, policies, and codes. And you'll see some of that work today. And also, I think the work of our students might be presented today. Fadi is our own alumni from our Masters of Landscape program and a post-professional Master in Landscape and Architecture from Harvard GSD. And he attended Waterloo for his undergraduate degree. He is the recipient of several awards and has published in numerous applications. I will name a few outstanding that caught my eye, including the Fulbright Fellowship, the Heather M. Reisman Gold Medal in Design, the ASLA Certificate of Honor, the Jacob Weidenman Prize, and was the 2015 recipient of the Charles E. Beveridge Fellowship by the Olmsted Friends of Fairstead. So without further ado, I welcome Fadi.
All right. Thank you so much all for being here. I just wanted to first start out by defining what climacteric is. I know that it's a Greek word borrowed from biology, but it's also come to mean in English a kind of critical period or event, or as an adjective, as something that's having extreme and far-reaching implications or results, something that is critical. And I would say that the climate crisis might be reaching a kind of climacteric. Just like this year and the year before it, in February of 2017, was a summer of record heat in Australia. Scott Morrison, then Australia's Treasury Secretary and today Prime Minister, waved around a lump of coal in the Parliament during question period. "Don't be afraid, don't be scared, it won't hurt you," he said. "It's just coal." With these words, Scott Morrison taunted the opposition, attempting to ridicule any commitment they might have for renewable energy. Right now, on the outskirts of a hyper-modern first-world metropolis, at the end of a year in which the public seemed finally to wake up to the dramatic threats from global warming, a climate disaster of unimaginable horror has been unfolding for almost 3 full months. What accounts for the indifference? Asks New York Times columnist Richard Flanagan. There are all the usual factors, the desires to look away, to avoid contemplating the scariest aspects of contemporary life, the short-sightedness of the media's reluctance to cover climate disasters, at least as climate disasters, and the forces of denial that are now seemingly embodied, but as much in the Australian Prime Minister, who was elected on a platform pitched against climate policy, and who was also taking a long holiday in Hawaii while his country burned, as they are by Donald Trump and Jair Bolsonaro. The response of Australia's leaders to this unprecedented national crisis has not been to defend their country, but to defend the coal industry. Australia is a burning nation led by cowards, said the New York Times columnist. Australia today is also ground zero for the climate catastrophe. This situation is eerily reminiscent to the USSR in the 1980s, the writer says, when the ruling apparatus were all powerful but losing the fundamental moral legitimacy to govern. With other obligations in the Pacific and Southeast Asia, even the military was not necessarily staffed to handle a looming climate crisis. If this is the new normal, the model is broken. Since the 1980s, Australia's scientists have been sounding the alarms of the impact of climate change on their country. Fragile ecosystems like the Great Barrier Reef, and in Canada, the Arctic, and the rainforests are the first indicators of this climate crisis. Last year, the Great Barrier Reef suffered widespread bleaching. It's damaged 95% of the reef's northern end. And this year, without hardly enough time to recover, the middle third of the reef has also suffered widespread bleaching. What the climate crisis has proven is that we need to find new ways to render visible the links between our actions and the direct physical impacts they have on our planet. This is a map drawn by Hadi El-Shayeb, who was an MLA student who did this drawing for his thesis last year, that links the immediate adjacencies between the Great Barrier Reef, which you see here in coral, and all the mining and extractive industries just to the west of them in Queensland. Each cross is a different mine. Each red dot is a rainforest that is being logged. And every white dot is a shipping container carrying the dirtiest form of fossil fuel energy out into the world to be burnt. Each dot is millions of tons of coals that contribute to the heating of the planet and the degradation of the environment. Australia is the world's largest exporter of coal and liquefied natural gas. It is also its most profitable export, valued at $46 billion a year. This means Australia is one of the biggest profiteers of climate change. So this also goes hand in hand with a narrative that is spun by the media. We should all remember that News Corp executive chairman Rupert Murdoch also comes from there and has a huge influence on how the narrative is spun. Yet quantifiable impacts and the inextricable links between greenhouse gases, the heating of the planet, and the rate, frequency, and intensity of natural disaster has been undeniable. Let us not forget that in 2019 alone was a year of record-breaking on so many fronts. This NASA animation here shows the concentration of carbon monoxide generated by the wildfires in Brazil. And this summer, the country experienced record wildfires, and by August 23rd, more than 2,500 active fires were recorded. And it goes without saying that in both Australia and Brazil, the loss of wildlife, biodiversity, and the release of so much greenhouse gases from these vital carbon sinks will have massive implications on our planet in the years to come. Notwithstanding the impacts these fires have on a large number of indigenous peoples living predominantly within remote regions of these colonized lands, and have the most to lose from land use changes related to deforestation, urbanization, and forest fires. The 2017 Atlantic hurricane season was the costliest tropical cyclone season on record. The damages were at about $300 billion and from left to right, these are Katia, Irma, and Jose. But then the following year, the US was hit by 4 Category 4 hurricanes: Harvey, Irma, Maria, and Michael. That's the most ever in 150 years of records. And these storms decimated Puerto Rico, drowned parts of Houston, and rattled most of Florida. Triggered another year of record damages, this year at $306 billion, eclipsing what was thought to be devastating in 2005 when Hurricane Katrina hit. On the other side of the planet, Typhoons and cyclones were also devastating Asia, pointing to a global trend that links climate change to the intensity, frequency, and severity of storms. Just a few days ago, Forbes released the amount of money oil firms spend on climate lobbying. This has been ongoing for over 30 years, where they've been sowing doubt about the reality of climate change, hiring some of the same PR firms that attempted to downplay the negative consequences of tobacco on people. And on average, oil companies spend $200 million a year on lobbying to control, delay, or blocking binding climate policy. Their campaign is based on 5 main pillars that if we're conscious of, we can start to tackle. The most powerful and clearest one is science denial. And this is the type of denial we're all familiar with, where they start to state that climate change as a number is not settled. And deniers suggest climate change is just part of the natural cycle, and that climate is always changing. The second is economic, where they say it's too expensive to fix. And the third is this myth that they argue that climate change could be good for us, where they suggest longer, warmer winters in the temperate zones will make farming more productive and our lives a lot easier. These gains, however, are often offset by more forest fires or more frequent heat waves and storms. More importantly, we have to remember that 40% of the world's population lives in the tropics. And so if there's a climate crisis, lastly, climate change deniers argue we can't take action because other countries are not taking action. But not all countries are equally guilty of causing the current climate change. For example, 25% of human-produced CO2 is generated by the US, another 22% by the EU. The entire African continent produces less than 5% of the emissions. And deniers will tell you that there are problems closer to home that we need to be bothering with. This is the message the $30 billion war room funded by Alberta's taxpayers is set out to do, which also includes a $2.5 million public inquiry into the allegations that foreign interests are funding a campaign aimed at denigrating the reputation of Alberta's oil. But it has come to light in recent years that major fossil fuel companies know well in advance that their activities were gravely destroying the planet, even as they waged a relentless war and campaign to confuse the public opinion. So this is a correspondence that was released between the former oil CEO Robert Peterson, this is ExxonMobil's Canadian branch, and some of his research staff. He says there's absolutely no agreement among climatologists on whether or not the planet is getting warmer. He added that carbon dioxide is not a pollutant, but an essential ingredient of life. The benefits of carbon dioxide aside, experts at his company knew with confidence not only that climate change was real, but that Imperial Oil's activities were causing crippling harm to the environment. Let's remember that our own premier said it's not a waste of taxpayers' money to spend $230 million to axe 800 renewable energy products across the province, including many wind turbines. I'm so proud of that, added Ford. I'm proud that we actually saved taxpayers $790 million to cancel those terrible, terrible wind turbines. If it simply comes down to money, Bloomberg Business recently shared a UN report putting the estimate of dealing with climate change at $300 billion. That's the money needed to stop the rise of greenhouse gases, and buy us 20 years of time to fix global warming. This is the equivalent of the GDP of Chile, for example, the world's military spending every 60 days, and the net worth of just 3 people. Jeff Bezos, Bill Gates, and Warren Buffett. In spite of what seems to be a dire and hopeless situation, we also need to recognize that the world is opening up to a fundamental shift on how we should live and operate. The word resilience alone has become the buzzword of our time. And in its simplest definition, it comes to mean the capacity to recover quickly from difficulties and to become stronger and better because of them. As designers, we have to be inherently optimistic. It's our job to shape and build the future. And for our purposes today, climate resilience sits at the intersection of 2 things, mitigation and adaptation. Mitigation is the big picture, where we tackle the problems at its root. For example, shifting from fossil fuels to renewable energy, cleaning and recycling water, and reducing waste, and this has to happen at a global scale. And adaptation, on the other hand, which is our localized responses to climate change. Like the redesign of our infrastructure, the redesign of our buildings, and the rewriting of our policies need to start to reflect this new reality. And adaptation is inherently nuanced and extremely context-specific. Context matters a lot when we talk about the future of climate adaptation and resilience, and the world is finally acknowledging the vital role Indigenous peoples play around the world in fighting climate change. This is a recent UNESCO report titled Local Knowledge and Global Goals, which explores the ways that Indigenous and local knowledge systems contribute to the understanding and mitigating and adapting to climate change. For the over 130 million Indigenous peoples worldwide, climate impacts are expected to be early and severe due to the locations and the high-risk environments. And to face these challenges, they're mobilizing their in-depth knowledge of their traditional territories that have been the source of their livelihoods for generations. Indigenous knowledge operates at a much finer spatial and temporal scale than science and includes cultural understandings and narratives of how to cope with and adapt to environmental variability and trends. So it's just important to think of the intersection of those two things when battling issues of climate change. The science has been proven over and over again, but is it enough to shift the conversation? One of the most noticeable impacts of climate change is flooding and sea level rise, and this will be the kind of focus of the conversation today. Today, about half of the world's population lives within 100 kilometers of an estuary, where 8 out of the 10 largest metropolitan regions are currently situated. That is roughly 5 billion people that live at the point where biodiversity is the highest and the earth is most productive. It is a ground that is neither wet nor dry, but has always and will be in a state of constant flux, or terra sorta firma, as I like to call it. We've always lived in them, from the Nile, from ancient Nile River deltas to the world's most populous cities like Shanghai and New York, and from Venice to New Orleans, people once mastered living on this terra sorta firma. So taking a look back to pre-industrialization, water and the environmental context that they've been living in had been integrated into the urban form. This integration took into account large-scale systems that created horizontal city forms appropriate for their period of development and their context, creating sophisticated systems of drainage, agriculture, urban settlements, and land subdivision, such as these Dutch polders that have been in place since the 1200s, where low-lying tracts of lands, roads, fields, and waterways formed this sort of artificial urban landscape entity. They all, and this is a theme that actually finds itself in many of those delta locations all around the world. And they all operated on the premise that in order to live on or in that landscape, the built urban fabric needed to first slow and absorb water to prevent flooding, rather than dispose of it as fast as possible. Its infrastructure must retain, purify, and improve the quality of that water, and in that process create net positive ecosystem services, while also activating the social public realm through the coupling of civic, economic, and performative uses. So what went wrong? Knowing that we've mastered living in these contexts for millennia, why are cities today increasingly challenged to adapt to climate change? The first reason is that between 1950 and 2030, urbanization patterns have dramatically shifted. The rate of growth is unprecedented, where it is estimated that another 2.5 billion people will urbanize estuaries by 2050. The second reason is that we have paved our world. This map shows where there's an at least 10% impervious surface area, and because of this type of rapid urbanization, the watersheds are now compromised in their natural ability to clean water, produce biodiversity, and control flooding. In 2013, the Rockefeller Foundation pioneered the 100 Resilient Cities initiative to help cities build resilience to the physical, social, and economic challenges that they face. So right here in this very room at the Daniels faculty in June of 2019, the City of Toronto launched its first resilience strategy with a big event and a public exhibition that took place outside. The launch was timed only a few weeks after this comprehensive report on climate change by the federal government was released. This is the first of its kind, and I just want to make this note that the reason why something like this exists was a very critical decision on behalf of the government to make sure that we measure and quantify the issues if and in case there's been a shift in government. This multi-volume report is about how and why Canada's climate has changed and what changes are projected in the future. The findings conclude that temperatures in Canada have risen by 2.5 2.3 degrees since 1948. That's almost the double global average, most notably in the Arctic. And it also points to a shift in precipitation patterns where some regions of the country are facing more severe droughts while other more extreme rainfall, especially in the summer. In Toronto's case, the impacts of climate change also mean that we will have more extended heat waves, more extreme weather both in the winter and the summer, with observable changes including more frequent flooding and ice storms. There's some key statistics that are of interest. Close to 50% of our carbon emissions come from heating and cooling our buildings. If this is not something that we should be pioneering here, then where should we? 41% from transportation and 11% from waste. And in that regard, a recent survey found that 78% of the city is concerned, residents of the city are concerned with climate change. 92% agree that it will threaten their personal health and well-being. 91% of Torontonians agree that everyone should reduce their emissions, and 48% simply don't know what they can do about it. So this is something that is kind of paralyzing. So this kind of resilience strategy is a first attempt at directly dealing with climate change in our city. And it kind of sets out a series of principles and actions to help Toronto survive, adapt, and thrive. In this report, Torontonians identified 6 challenges, and I'll only speak about 2, that are meant to sort of help the city deal with its resilience issue. The first central pillar is establishing a connection between equity and resilience, where Toronto's disappearing middle class is seen as a huge risk for the future of the city. You can see in these maps produced by Professor David Halchensky, who's a professor here at U of T, that shows the shrinking middle class in yellow, the rise of the lowest average income bracket in red, and the highest individual income bracket by ward in blue between 1970 and 2015. So the strategy calls out the need to continue investing in neighborhoods, community services, access to education, housing, and transportation to avoid the complete collapse of a viable and stable middle class. Also worth noting that the wealthiest wards also live along our main subway lines. The second key pillar is flood resilience, particularly urban flooding. And this is a photo of Toronto's islands, which were underwater for the second time in 3 years. In both years, Lake Ontario levels reached historic heights. And it's important not to confuse this with sea level rise. Toronto does not have, the Great Lakes don't have a sea level rise problem. They have an issue with extreme precipitation that has been taken over the spring and then the summer that create massive overland flooding, so runoff from urbanization and paving of our watersheds. And the long-term forecast for Toronto calls for hotter, wetter, and wilder weather over the next 50 years. More than 5 inches of rain fell in a few hours in a rainstorm. The Danes call this a cloudburst, which I think is a really kind of interesting way of branding the issue. And this happened multiple times in the last few years. And the government finally began paying attention when Union Station, which had just recently completed a decade-long, multi-billion-dollar renovation, kept flooding year after year. So many of the commuters kind of took notice and began posting things like this on social media. This map on the left shows Toronto's glacial topography, so the networks of ravines and the edge of the Lake Iroquois, and on the right is a map of all the red dots that include all reported flood calls from the last couple of years. You'll notice a higher concentration of flood calls on the northwest side of the city because of 2 reasons. The first one is the geologic ridge of the old Lake Iroquois shoreline that traps moisture coming from the predominant southwest wind. And the second is the huge concentration of impermeable surfaces around Pearson Airport and all the logistical areas around it, especially along the Humber, Mimico, and Black Creek watersheds. We're going to stop for a minute here to observe the moment of silence. It's also important to note one more thing that is critical about where these flood calls are is the overlay of the lowest income. Some of the lowest income neighborhoods within our city also happen to fall in areas of the city that are also the least permeable. So the resilience strategy calls out the need for us to understand our terrain in relation to urban development and to invest, preserve, and enhance networks of green open space in order to mitigate some of the effects of urban flooding within our city. And to think of green space not just as civic recreational uses, but also as a form of infrastructure. So the strategy also calls out some of the things that we are doing really well. And in this case, it kind of recognized the important role the TRCA plays, which is the Toronto and Region Conservation Authority, that has spent over 70 years kind of promoting and working with sustainable city building. And it's also a nod at some of the most progressive things that our region has faced. So the TRCA was created after Hurricane Hazel hit the city in the 50s, which spurred watershed-scale regional planning and development. And this is one of the main reasons why our ravines today are protected and why they continue to play a really important role in the overall resilience of Toronto. The overlap of climate risks and social vulnerabilities also manifests itself in a handful of key areas, most specifically in Toronto's aging high-rise rental apartments. These towers represent, according to the strategy, the single most pressing urgent priority for the city's resilience. So over 500,000 people, who are mostly within the middle and low income brackets, live in hundreds of these towers that are 35 years and older. Toronto has the highest amount of these towers anywhere in North America, and amongst their many issues is that they're extremely energy inefficient. We know how hot they get in the summer and how cold they get in the winter. And it's also very difficult to go up the stairs if you're an elderly couple or a family with children if the power goes out. And we also know that the city is facing a major housing crisis, so we can't afford to lease these towers. Important to note is that these towers also sit on huge swaths of green open space, many of them in the suburbs of the city. Once seen as an irredeemable negative urban trait, we've always called them the tower in the park problem. Now we recognize, however, that there's a huge value in these open spaces as green, as carbon sinks, as places for healthy tree canopy and permeable open space that can also work to mitigate the urban runoff. So the challenge for us is to find ways to think of how to program these properly and how to restore their connectivity into and through the rest of the city. So now that I've set the conversation overall around the kind of urgency of the climate crisis and the discourse around resilience, I'll talk a little bit more broadly about the role of design in its capacity to help cities prevent, mitigate, and adapt to climate change. Over the last 60 years, there's been over 60 open call design competitions that we've counted that ask interdisciplinary teams to imagine climate resilient and adaptable future for countless locations all around the world. We began to collect, catalog, and categorize them in order to extract a set of design strategies and metrics that we can point to and understand as foundational principles of contemporary resilient design. I'm sorry for my students who've seen these before because I repeat them over and over again, but they are really critical. The first is that we are able to boil these things down into the concept of the first thing that we need to do is understand the connectivity and read the landscape. The second is to design open-ended spaces for flexibility in program and use. The third is this idea of the landform as a fail-safe and as a buffer. The fourth is the integration of green, blue, and gray infrastructure. And the fifth is the idea of the landscape as a filter. So all of those things function as a kind of underlying strategies, metrics, and frameworks that have informed and manifest themselves in different ways in multiple locations and in multiple design proposals. And then each one of those things are sort of embedded through and from three main kind of apparati. The first is this idea of terrain. And it's important to remember our agency as designers in shaping terrains and topographies in an era of climate change. In large quantities, we've been shaping and engineering artificial terrains into the most fundamental of all landscapes and a precursor to any development, which is land itself. And in a time where coastal conditions, associated activities, and abutting settlements are especially vulnerable to climate change, the process of coastal land reclamation for urban real estate has become a profound challenge. To many people's surprise, sand is the second most consumed natural resource on the planet after fresh water. Only the sand weathered by water, so dunes, rivers, coastal conditions, is sand that we can use for concrete and for land reclamation, while the abundant desert sand that has been weathered by wind, which is round, is rendered useless, especially in concrete. So 40 billion tons of sand a year goes into urban development. That's twice the amount of sediment carried by all the world's rivers combined. And seemingly infinite, it's now become a scarce resource. China alone consumed more of the resource making concrete in the last 3 years as the US has used in the last 100. So think all the bridges, all the dams, all the ports, all the airports, all the buildings in the last 100 years built in the US. China used more of them in the last 3. Okay, so it's becoming such an issue that just last year, the United Nations created the Sand and Sustainability Report for Environmental Governance. So it's important to remember that this material goes into the very things that we in the room shape and build and construct. In some places like Singapore, it's a matter of national security, where they've been moving sand from one neighboring country to the other in order to expand their own shoreline. And once the Singaporean Minister of National Defense infamously once said, lazy Malaysian sand is better off in Singapore, where it will have a better work ethic. So we've been working in my lab to kind of diagram and understand the process of land reclamation so that we can intervene within the process. And also the role of different conglomerates and their associated technologies that have been shaping and reshaping so much of the earth. Globally, the success of projects on reclaimed land have been proven to be variable. In some places, the cost of reclamation has not added up to the value of the original design, leaving behind acres of undeveloped land. And nowhere is this more evident than in China. China reclaimed 13,000 square kilometers of land and expanded its coastline by over 2,000 kilometers. This resulted in a reduction of 50% of China's coastal plains and wetlands. And we now know how critical these wetlands are and coastal plains in both biodiversity, but also in helping with shoreline defense. And this practice continues today, where new artificial terrains are being constructed at a rate of 700 square kilometers per year. And what you're seeing here is some drone footage that we took in Tianjin, just south of Bohai Bay. So we started to compile a case study atlas of all these projects on reclaimed land in order to analyze them through these series of matrices and indices to assess the viability of these projects and their kind of environmental performance. I just want to note, this is Manhattan, right down there, for kind of a scale comparison. So we then expanded the atlas to include global case studies that range in age, size, and scope to better understand this global paradox that faces many coastal cities, where the waterfront continues to be prime real estate, but it's also the most vulnerable to flooding. Reclamation is not a new practice, and almost every single city has reshaped its coastline, but some cities did it better than others because they hired good designers. The now celebrated Back Bay area in Boston was once a noxious tidal swamp, so the sewage water that infiltrated the area created a serious health problem. And by 1877, Boston City Council authorized the acquisition of this land in order to lay out a park in the Back Bay. It's important to note that this area for the park was also identified as part of a larger metropolitan park system for Greater Boston, laid out by Charles Eliot in the late 19th century. By 1875, there was a proposal to make a park in the Back Bay in order to alleviate the flooding and sanitary problems it was facing. In other words, they wanted to create a stormwater park, which itself is an extremely radical idea for its time. Frederick Law Olmsted, for those of you who don't know who Olmsted is the guy who designed Central Park, argued against a conventional masonry storage basin and instead insisted on a radical proposition that, I quote, juxtaposes an artificial salt marsh with the city. It would be novel, he said, certainly in labored urban grounds, and there may be a momentary question of its dignity and its appropriateness, but it is a direct development of the original conditions of the locality in adaptation of a dense community. Olmsted devised a plan that would solve the drainage problem as well as transform the Back Bay area into a hydrological public park. Again, extremely revolutionary for its time. Olmsted proposed a landscape that had the same visual characteristics as the original marsh. However, it was not a restoration project. The fens, which this area came to be called, was a fluctuating living system of some 130 acres. It required massive construction efforts to stabilize, where the land was then graded to precise contours that were specified by Olmsted's plan. By 1895, the park portion of the Back Bay was completed. The aesthetic of the fens was wild. Vegetation ranged from brackish grasses to ornamental trees. You have to remember this is like the Victorian era, right? Bourgeois people, right? And even though this fear of a wild aesthetic might have deterred the bourgeois population of Boston, his strategy ultimately proved to be extremely successful from a performative point of view, and many of Boston's most famous institutions ended up relocating to the fens, like the MFA and the Isabella Gardner residence. The filling operations of the entire Back Bay took approximately 6 years to complete, and its main goal was not just to restore the waters issue, but to enable the construction of the Back Bay development to the north and east, which is a massive real estate enterprise. The new infill, that now doesn't flood anymore because of the fens, included both commercial properties, streets, as well as a new park that was providing a new urban surface for a planned urban unit. The Esplanade Park along the Charles River, the fens, and Commonwealth Avenue were not merely open spaces, but a performative landscape armature that enabled the construction of an entire urban district on a manipulated terrain. So from flood defenses that doubled as parkland to the cleansing properties of stormwater wetlands, it had many of the same characteristics that we would today call a contemporary resilient design. One of the few contemporary examples of this precedence sits right here on our portlands and the redevelopment of the lower Donlands. So the winning competition by MVVA for the redesign of the portlands deploys a very similar complex and comprehensive landscape strategy as the Back Bay fens. Starts out by the artificial renaturalization of the Don River, and they use landforms, planting, and buffering strategies to protect from flooding, but also to enable a new development to take place on there. This new floodable artery acts both as a habitat for wildlife, as a public amenity, and as a measure against flooding. But most importantly, it enabled development on an area that has been lying dormant and derelict for decades, juxtaposing marsh and city on a completely artificially constructed terrain. Again, this is not too different from Corktown Common just to the north, which is one big floodable protection landform park that enabled development to proceed just to the east, just to the west of it. So by giving the river the space to flood, it's not just an eco-infrastructural strategy, but a key catalyst for future development and investment on the water's edge. We have a history of the city of shaping and reshaping the terrain. So when the City of Toronto's Island Committee was considering the redevelopment of our harbor through dredging and filling, in 1902, they also hired Olmsted to come up with a plan that would look after the placement of waterways, roadways, and bridges. Designing in section, it included landforms that used the dredge materials as breakwaters on Lake Ontario, a series of protected beaches as open buffers for activity, a promenade, and a terraced treed boulevard followed by a dike-like landform. When all these landforms were aggregated, they acted as a redundant buffer of infrastructural networks that both connected the city to the waterfront and the waterfront to the city. And this is a section near Lakeshore and the Queensway where the GO train kind of currently runs today. Today, the TRCA is also deploying a very similar strategy to protect the islands from future flooding. So, to re-emphasize that many of these ideas are not rocket science, and many of them find new ways to relive themselves. In essence, when we shape new terrains, we now have methods to assess risk, including liquefaction, erosion, and flooding. And using things like generative design, we can now deploy new techniques that optimizes cut and fill operations that become responsive to live feed data, such as currents, tides, salinity, pollution, to create new landform types that are optimized to respond to things like flood risk, land value, and access to infrastructure. And these are just some experiments that we were doing this summer to kind of test this idea that if we're creating new terrains from scratch, how can we have certain gradients of risk of inundation and of flooding that will help us think of how we cut and fill and how we really reclaim new coastlines. The next phase of the deployment is this idea of linking buildings, parks, and infrastructure to this newly reassembled terrain. In November of 2016, this octopus made its way into a parking garage in Miami Beach and instantly became a social media sensation. A king tide flooding event, and the king tides occur when the moon is closest to the earth, so the tides are really big, carried this creature deep into the city, into the urban fabric of the city. And because water levels in the Biscayne Bay near Miami have risen so much, salt water from the sea and the animals it carries with it has been infiltrating deep into the city and its infrastructure, creating what they call sunny day floods. So this recent study from 2006 showed that high tide-related flooding has soared by 400%. These are photos I took in Fort Lauderdale a couple years ago during a king tide, where salt water was just bubbling up from the sewer grades, kind of eroding the sewers and also just filling the city with seawater. So with nearly 20 million residents, South Florida is one of North America's fastest growing regions. And as it continues to urbanize, it's easy to forget that cities like Miami, Fort Lauderdale, West Palm Beach are in fact surrounded by water from three sides: the Everglades to the west, the Atlantic to the east, and the aquifer just below their feet. Yet in South Florida, like many other estuary regions that I mentioned earlier, this underlying geography and landscape is a place that is feared, and in the psyche of people, it's filled with pythons and alligators and mosquitoes and mythical creatures, where it rains blood and humidity is at 1,000%. So over the past 60 years, the Army Corps of Engineers built over 35 miles of levees and 2,000 hydraulic pumping stations to drain a metropolitan area of 15,000 square kilometers every day, creating impressive expanses of infrastructure that goes on for miles, and reshaping hydrological flows at scales never thought possible, in order to create a type of urbanization that is seemingly detached from its context. This sort of repetitive pattern of insular private residential developments that stretch infinitely. This is just a taste of what South Florida looks like. And this early 20th century land speculator famously once said, "I bought land by the acre, I bought land by the foot, but by God, I've never bought land by the gallon." So it just gives you this idea of the saturation of this place. And so over the past century, Floridians have put an estimated $100 billion worth of property below sea level that will be below sea level by 2030. And let us take a moment to admire that someone drew, designed, and built these things. And what's worse is that many thousands are flocking to buy them and live in them. And South Florida is one of the fastest growing places on the continent. While scientists have been sounding the alarms for years, and scientific papers such as this one confirms that Florida is in even deeper trouble than previously imagined. Yet, this is what most architects and planners are doing in Florida. There's fancy glass towers designed by starchitects, and full European plazas designed by new urbanists. Beyond the speculative real estate that takes place down there, the urban codification systems mostly deals with formal things: the way the building looks, how far it's set back, what is its adornment looking like, versus any real serious systematic or performative ones like hydrology. So they keep perpetuating more of the status quo. In fact, in places like Davie, Florida, the Southwest Ranch style is highly enforced for all new buildings. So they would rather their towns look more like Southwest ranches or Southwest architecture, decorative architecture, than any of the ones that would necessarily be dealing with serious floodings. And this is enabled by the myth that by simply dividing the region from its natural context with a massive levee, you can generate a condition in which 1/3 of the county is urban and you can build anything you want on there, and 2/3 that is Everglades. You just push the natural context out of the place by putting a wall in the middle. So you end up with two coasts on either end, one on the Atlantic and one on the Everglades, when in reality it's one singular interconnected condition. So this very progressive and unique form of regional government dealing specifically with climate change and adaptation was formed in 2010. The 4 southeastern counties kind of got together and created the Climate Change Compact in order to coordinate mitigation and adaptation activities across county lines. And I've been working with Broward County for the past 4 years. And this relationship resulted in a series of 4 design studios taught both at U of T and MIT between 2013 and 2017, involving some 60+ students of landscape architecture, urban design and planning, as well as some 20+ municipal planners, policymakers, and engineers. All the studios started with this animated sort of analytical mapping exercise that compiled the historic and current cartographic information and made sure that it was dynamically animated. So you would understand something like weather patterns, tidal variations, and the changing water table. So no map is ever static, and no map is ever only showing one moment in time. This was followed by an intensive exercise in the form of a codification workshop, where the design students were asked and immersed to look at the local planning policies and land use zoning codes. Nobody really liked this part. Everybody was complaining a lot, but we learned a lot because what we found out is that most of our designs would technically be illegal in a place like Florida. And anything that is sort of innovative and forward-thinking would be met with a lot of contestation and with a lot of issues. The code continued to perpetuate static urbanism. So armed with a strong understanding of the context and existing policies, the students began to imagine a series of catalytic, responsive, and multi-scalar design moves. I'll only show a very small sample of these projects from the latest studio that was awarded the 2018 Studio Prize and Sloan Award. This first project envisioned a way to make the rural ex-urban communities a major player in the restoration of the Everglades. They proposed a toolkit of topographic and phytoremediation strategies for canal infrastructure and site grading that treated the agricultural pollutants as they entered the stormwater stream. As per their new system and code, all the ditches and swales were regraded and vegetated as part of a larger connected network that lengthened the distance between the source of the runoff and the Everglades, and in doing so, naturally filtering the water along the way. This project addressed the sunny day flooding phenomena I talked about earlier by envisioning a new road-canal infrastructural hybrid in Fort Lauderdale's islands. They proposed networks were called the vias, which were a cross between a street and a canal, and they would specifically mitigate the tidal water that's coming in with the tides and create an alternative pedestrian circulation network. This provided shade and extended the public realm through this kind of tiered system. This project established a relationship between topographic elevation, so how far away you are from sea level, and the massing and density and heights of buildings. So the code enforced this correlation between height and distance from both how far you are from the sea and how far away you are from the water table, specifically along the ridge. They also thought about things like solar orientation, where the maximizing of shade on the streets is encouraged. So all the buildings had to tilt in specific angles to maximize passive heating and cooling. This last project saw the potentials of creating new west-facing shoreline along the Everglades coast. By thickening and inhabiting a redundant series of berms and levees, a linear city would emerge, necessitating new building typologies and open spaces to be imagined. Lastly, I think designers need to think of new ways of institutionalizing resilient design in these hyper-localized and through hyper-nuanced and localized codes. Instead of inheriting the codes, we should be writing these codes. So this is the kind of launching point for this point, where on the right you see the current land use zoning map of the Hollywood area of Broward County, and on the left you see the 2 feet and 6 feet estimated flood projection overlaid on top of that future land use zoning map. And let me remind you, 2 feet is not that much. It's like 2 foot long subs. And it's a little weird when you think that you might be creating a future zoning map for 2060 and not think about putting the future 2060 flood projection maps on top of it. So after we did a survey of all the kind of existing regulatory codes, we understood that there is actually no way for us to overlay these things and think of them congruently. There is an inability for all the administrative planning tools to accommodate any type of dynamic or systematic process to shape the future of the city. So in response to that, in collaboration with the MIT Urban Risk Lab, we've been working on developing this platform that allows residents and officials to better understand the relationship between built form urban codes and the underlying environmental conditions in real time. So using digital descriptions of ecomorphological attributes, which is a fancy way of saying soil, geology, and permeability, base flood elevations, seasonal water table heights, and storm surge, we've been utilizing a bunch of algorithms to begin to understand how to create a series of districts or zones that can inform targeted intervention and direct future built form. And this is the difference the land use categorization system that I mentioned produces. So on the left is the approved 2060 Broward County land use zoning map, and to the right is a proposed land use clustering method that takes into account these environmental conditions. So you start to see a much more nuanced and highly descriptive type of land use zoning map that is associated with very specific regions and conditions within the county. So we've been working on zooming into specific districts where we can start to select parameters on a slider bar, for example, to identify within the neighborhood where specific parcel levels of information, like parcel level information like water storage potential, lot coverage, permeability, building height, age, and value. And so as the water levels fluctuate, specific clusters may begin to serve as productive, infrastructural purposes, as well as other types of development tools and ecosystem services. So this kind of starts to generate a set of scenarios that are responsive to calibrated parameters, inputs, and projections. So we can start to go from an area that is zoned for one possible future to one that generates a set of responsive scenario-driven urban proposals. Over the last few weeks, I've begun compiling with this awesome team of designers. I think I see Hillary here. And we've been working on this very difficult drawing for 4 months, which from here might look pretty simple, but what it is over 40 resilience strategies and prototypes from around the world compressed into one 5-foot-long section. This includes strategies that are infrastructural, tectonic, spatial, and at different scales. The goal, kind of very similar to kind of Olmsted's section drawing, is to highlight the need for design to integrate terrains, assemblies, and codes for a resilient urbanism. The next step we will be doing here is animating this section so that you would see it through the dimension of time and other types of vulnerabilities. And so just to close here, I just want to quote I'll end by quoting this landscape laureate, J.B. Jackson, who astonishingly talked about climate change to an audience of urbanists and designers almost 50 years ago. So in this conference on urban design, he said that the beaches along the Gulf and the Atlantic are doomed to destruction. They are remorselessly eaten away by the sea. Geographers tell us that we are being driven inward by the rising ocean at the rate of 1 vertical foot a century. When asked about the future trajectory of the design professions in a changing environment, he responded, "There are many reasons to believe that the natural environment cannot be saved in its present form. It can be summed up by saying that everything conspires against the permanent form for the natural world around us. And so we need to embrace change and uncertainty by designing for it." At the end, it's important to remember that in an age of extreme uncertainty brought upon by the climate crisis, we should first break down our professional silos, question the binaries of wet and dry, land and water, and dissolve them into design gradients that respond to more uncertain futures. Thank you.